I realize this is literally the third video I'm making now where I look at a programming language, but I don't know. A few days ago I asked Claude, what are some popular C alternatives? And it said Odin and Zig. And actually that's about it. But then I also heard about C3 and Revo, which I did my last video on today, that literally came up into my YouTube feed. So I looked at that. And yeah, so there's C3. I also have Joule, which is another language. I don't know if that's a C alternative. It's kind of like C++ as well. Anyway, so in this video I want to look at C3. What do I know about C3? Nothing. I kind of heard about it, but I didn't really think about too much about it because no one really talks about it. The only reason I was reminded about it was because what's his name? Soding, right? TS Odin, whatever. He mentioned it because I searched like videos about Odin, and there was one video from Soding which is like, what's your opinion on Odin? And his sentiment was that we don't need Odin, you know, you already have C3, whatever. So now, to my understanding, C3 isn't really that drastic. Like it makes C nicer to use, like more ergonomic, but ultimately it doesn't do like anything crazy like Zig does, like nothing drastic. So it's very simple, and I don't even know if C programmers like C3. I guess because they just don't see much of a reason to change. But anyway, I'm gonna look at it because I think it might be interesting. So we got Hello World here. So my assumption is that this is very similar to C, and the only main difference is that well, actually, we can read it, can we? It's a revolution. Sorry, it's an evolution, not a revolution. The C-like for programmers who like C, although programmers who like C simply don't like C3. I mean, I'm sure many do, but I think C programmers just aren't going to change their ways. They have what they have, and until nothing would change it, honestly. Like it's like C's fine if you're used to it, right? Like if you can be bothered to learn a more ergonomic language, then you know who's going to stop you or force you to. But you can mix C with C3 projects, which is very cool, as a module system, and it does have operator overloading, but without C++ baggage. So I do wonder how that will look like. I'm very curious. Compile time semantic macros. I do wonder how it works on like the C preprocessor. It might even be more powerful. Like generics in C are quite annoying to do. So I think if you're going to win over C programmers, really tackling C's again, like ergonomic issues would be really important. Because like there are some things in C that are just so annoying. Like not having namespaces, right? It's really annoying. Also, I don't know if C3 is out yet. It's on version 0.8. I think it's approaching 1.0, and I do wonder how popular it'll be once it does release. Obviously, it's competing against like Zig, but still. Gradual contracts. Zero overhead errors. Error handling that combines the best parts of result errors with the easy use of exceptions, and seamlessly with C. Okay, generic modules for generic types. Cool. Type introspection for compile time. So it does a compile time reflection as well as runtime. Inline assembly. Probably not going to use that too often, to be fair. Debug with safety, but like even just having that standard, because I know that in C it's not really standard how assemblies is inlined. It's different depending on the compiler. Debug with safety checks. Detailed stack traces. No more segmentation faults. That's cool. I don't know why they can't do that in C already, but I guess it depends on the compiler, right? So examples here, we got hello world. So rather than hashtag include, you have modules, so like proper module system, which is very cool. Honestly, like if you just take C++ and C and give it a good module system, it already becomes so much nicer to use. Because like the fucking like having to use copy paste include headers is such a pain in the ass for everything, and like just having modules would just make things so much easier. Like it would just remove so many of the pains. It's insane for like building like libraries and stuff. I mean. And then you have imports instead of include again. Sorry, so module defines the name of the module, okay, and then when you import, it's actually include. And then you do this, so standard IO. Odin has something similar, right? Yeah, it has package main and then import that. So that's interesting. Actually, I'm gonna pull up the Godbolt as well compiler, because it does have C3 support. Stop stacking, bro. I might need to switch to a new browser, because this thing, the ergonomics of Vivaldi are kind of pissing me off. So let's have like a C3. Not that compiler. Actually, I don't really care about the compiler. I care more about the output in this case. Please execute the code. Yep. Yeah. So I don't know why it's not actually printing the thing here. I don't know, like if that's a bug or what. Compiling. Because like it says execute the code, but it's not executing the code. So like what's going on? And this also looks outdated. 0.7. Yeah, I don't know. Maybe I can find a different one. C3 compiler online. I know I could just install it. In fact, maybe I should maybe I should just install it. Okay, let me install it for Linux right now on Arch. Just git and then what? Is that it? So let's do this. Boom. It's not source, is it? No. So C3C, git. Yes. Yes. Whatever. Defaults. Okay. Okay, so about 0.5 GB, which isn't too big actually. Mind you, I mean, like it's only a C compiler, right? So like it can't be that big compared to like C++. Okay. Is it building from source right now? This is my first time installing a compiler. Well, besides like GCC, I guess. Via this method on Linux. Using CMake. While that runs, I guess. Anything else I need to do? No? Okay. Where's it gone? Have I closed it? Oh yeah, right. I was on the docs. What's on Windows? So it's C3C compile. Okay. Then that's done. Yes. Okay. So C3C. Nice, we got it. So it's C3C compile with your file. A init is a new project, new library structure for init-lib. That's cool. And then you build. Sick. Without a project into an executable. So what's the difference between compile and build, I wonder? Just like without a project. Okay, sure. So let's do cd projects and make it okay. And let's make a little testing suite. So let's do C3 test, whatever, and seed into that. And then let's make a file. I assume the file extension is just C3. Yeah. Okay, so hello.c3. So what we do? So we do module hello to say this is our module. We import whatever you want. I don't have syntax highlighting for this. Yeah, I can install that. And for main, we'll do, I have nothing. IO print line, hello world. Already different from, well, I guess it should be puts in C, right? Okay, so then can I compile this? C3 compiler, compile hello.c3. And then do I specify a target or I print line cannot be found. Did you mean print out fn? It's print n. Is that for like print new line? I do like how so already the error messages are better, right? So it's print format n. No, just print n. But there is format n as well. Okay, good to know. Compile. It's compiled. It does the name of the file by default, which is useful. So I don't have to do like specify hello, because like on default for like GCC, like it'll just give you a as a compile as a executable name, which isn't very nice. And there we go. Hello world. Cool. So we got that set up. Let's go back into this and set up a new thing for the compiler here. Yeah. Okay. So let me also get TreeSitter for this. TreeSitter. How do I install a new language? I always forget. Let me do this. Yeah, okay, I'll do this. cd.config/nvim. Yep. And we'll go Lua, Kojo, lazy TreeSitter. I don't know if I've, yeah, I assume I do have it working. So let's do, I'll just add it here, I guess. C3. If I quit and open Neovim again, will it install? See this for how to add a new parser. Okay. Whoops. Holy lag. Is it this? Bro, take me to the fucking heading. Okay, whatever. Did not install? No. Failed to source comment string. Parser not available for language C3. Aww. Okay. So, whoops. Let's have to launch it again. So there's no C3 parser? How do I TS update? Okay, yeah, I'm kind of lost here, to be honest. Whoops. How do I add C3 parser / syntax highlighter thing to Neovim? I still haven't like really learned how to set this kind of stuff properly. Yeah, I use TreeSitter. Okay. So I just do this. So, okay. So how'd that go here? How would that be integrated into my current config? Oh, just here. And here as well. Okay. Fair enough. So what are we doing? So we require nvim TreeSitter parsers. So nvim TreeSitter dot parsers dot setup. Right. Nope. Dot get parser configs dot c3. Okay. Equals. God, sorry, it's just the keybinds. I have to like remember them from my computer now to switch between like different windows. Install info equals URL equals. This is the US apparently. The URL, sorry. What's it? C3 lang. Oh, it's official. That's cool. TreeSitter C3. Files equals, I am aware I'm mixing double quotes with single quotes, but blame Lua, not me, for supporting both. Source/scanner .c. Okay. Why is it a C file? Okay. Branch equals main, sure. Okay. And then file type equals C3. And then here I need to add it. See, that works. Check it is correct, first of all. Yep, looks legit. Oh, at the end as well, I guess, just for safety. Vim.filetype.add extension equals C3 equals C3. So it auto detects all my files. Okay, let's try that then. No such file or directory. Did I use a slash instead of like a dot or something? What happened? Okay, let me just... Okay, I did. How did I do that? Awkward. Okay, it's compiling. It's installed. Nice. So let me go here. Quit. Wrong one. Quit. And open it again. TS update. It's installed, but it's not highlighting. Yeah, I don't know if my TreeSitter actually works or not. I might have changed how I install languages. Oh, this is not good. Yeah, so TreeSitter is kind of broken for me right now, and I don't know why. Maybe it's because it was archived or something. Trees SJ. That's different. Vim be good. Under tree, telescope, surround, mason, marked view, Kanagawa, fugitive flash. Yeah, I don't know. I don't actually know what I have right now for my highlighting. How do I open the thing? Like the update thing. Update. What is it? There's like a thing that like shows all your plugins. Lazy, right? Yeah, lazy. That's it. Update. Okay. Yeah, so TreeSitter is here. Is it working? This isn't loaded for some reason. I wonder why. I genuinely wonder why. Am I even using... I don't know what I'm using right now. Okay, hold on. Let me look at my history. TreeSitter. Not really what I want to be spending my time doing right now. Okay. Despite doing this and it's seemingly installing, I don't get syntax highlighting for C3. TS module info. Watch it not be a command. Oh, it actually is. Okay. Looking for C3. It says no. It's weird. I think it installs and then like uninstalls it or something. Like it doesn't save it. I don't like. For some reason, installing with TreeSitter just isn't working right now for me. Yeah, reinstall it. Okay, well it's installed, so why is it not here? You know, I've got a C compiler for syntax highlighting. I've got C++, Haskell, HTML, like all of that is there, but C3 isn't. For some reason. Set file type, okay. Set file type question mark C3. Verifies active ts buff info. Also command. Check the queries, needs, highlight queries, actually highlight, check if they exist. Probably don't exist, but whatever. Yep, there is. It's empty. It does install when I ts install it, but then nothing changes. Yeah, ts buff info is not a recognized command. How old is my commit version right now? Should I change it back to a more recent one? Check health and from TreeSitter. Yeah, it just doesn't have C3. Holy troubleshooting. Yeah. Find out fuck that hasn't. But then what's the point of having this? Oh my days, bro. Okay, how about I do this? How about I don't use this commit and just do this. Does that work? I can't tell if that worked or not. I guess not. Cannot stat Lua master nested file directory. Right, so I get an error for that. Just fails everything. Sick. This is so sad, bro. Why? Man, Neovim. I need to learn. I really need to learn how to set it up properly, because otherwise this stuff just doesn't work. I tried putting to an old commit. Okay, yeah, I don't know, man. I'll just have to fix this later, because it just doesn't work. I mean, it did install this. It looks like just didn't get a syntax highlighter for it, unfortunately. What's this saying? highlights.scm. I mean, if it has them, why do I need to put them there manually? Like, can I not specify it here or something? Can I not specify the highlight files in my Lua config? What do you mean, yes? It's not what I asked. Okay. Oh my, bro, it cannot be this hard to highlight something. It's there. So what do I do? Okay, so first I'll do this. Local share envim. Local share envim. Yeah, looks right. And let's go to this directory then. Let's see if this exists. It does. Queries. Doesn't exist, right? Okay, so we'll make directory. What? Queries. Queries. /c3. Can I create directory in a file directory? Okay, then I'll just make this one for what? Oh right, P. Okay. Bah. -p. Okay. cd queries /c3. And then curl this. Okay. Hopefully it works. Control C, Control V. It's there. Now what? Go back here, quit, open. Update. Install. Sync. Clean. Check. Whatever, everything, bro. Okay. Nice! Okay, it worked. So I had to copy the files manually though. That's weird. And does indentation work? It does. Okay, right. So all that just to get fucking this highlighting, dude. Like I love Neovim, but like honestly, I'd rather not have to mess with this stuff myself. It's kind of just a pain in the ass. Right. So okay, so that's working. Right. Hello world. Okay, now we can go back to the actual thing. Right, so you have this, right? So what's different here, right? So if we compare this to a C file, and I will actually, let's say, well, actually, let's do whatever. So like, let's say I did C. Put this here. What? Why can't I put it below? I can put it there, but I can't put it here. Are you serious? Goofy tiling? Yeah, I can't. What? Why can I put it here? But I can't. Stop. But I can't put it here. I can. Okay. I can't. That's weird. Whatever. Right. So let's just zoom in here. Right. So cd hello.c. So so if this were a C file, there'd be no module hello, right? It'd just be hashtag include standard io.h, right? And then you have, instead of fn, you just do straight up with the type. There's no fn distinction. You just do the return type. It's not void. It's int because it returns a code. Main. By convention, you should do void to say it's empty arguments. You should return 0 at the end, and then you should also use there's no namespace, so you just do put straight up hello world. Right. Or if you want to use printf, you can, but you shouldn't in this case. Yeah, so obviously quite quite different here. First of all, main is void, which is interesting. I wonder why it's void, because like there is legitimacy to returning an int here. But maybe there isn't. I don't know. Maybe it's an outdated thing to do that. Prior IO prints n hello world. Yeah. Okay. So that's hello world. What else we got? Optionals. Fault def division by 0. Okay, so we're defining a fault. Function int question mark. Okay, so it's optional. Nice. So it's built into the syntax. Baked into the syntax. Divide int. If not y, return division by 0 tilde. Return x over y. Int a equals 4, int b equals 0. Divide that. It's an error. Int y equals x times 2. That'd be an error. If catch error equals x. If catch error equals x. Alright, so this is like a declaration. Oh, that's fucky. If b equals 0. Print fn had error. So this is a format new line. Using normal C format string thing. Return. And now x is a normal int. Whoa. Okay, so this is actually quite interesting. So let's have a look. First thing I actually want to test. Can I use like this? So first of all, can I use standard IO without importing? And I'll get rid of the C now. Yep. So can I do this? What was it? Compile. No, C through C. Compile. Hello to C. I can't. Okay. So let's say I do import it. Can I do this? I can. Okay. So I can use standard if I want to, but I don't have to. Okay, that's cool. And I'm guessing I can't just do print line, print n, right? No. But can I import just print n? Also no. What if I do it like this? Rust style. Well, no, because then it would work anyway, right? Okay. Interesting. Surely there's a way to like import only certain functions, but I guess we'll see. Is there like a using? No. Okay. So that then. So this is interesting. Return division by 0 tilde. Why is it like that? It's kind of goofy. But yeah, so this idea is cool, right? So rather than having x as like an actual error type, I mean like it is an error type, but like it works differently because like for Rust, right? Sorry, for Rust or like Haskell, whatever. The maybe type is like the type, like it's built into the actual type. So like it'd be like a maybe int, right? Or is it called maybe in Rust? Like an option int, whatever, right? X. But here, it's more like a mask over X. Like it's more like a wrapper over X, such that if you catch the error of X, once you've caught it and you've declared that you've caught it, if it exists, of course, then X becomes a normal int. So the wrapper gets removed. X literally becomes unwrapped. And you don't have to like move it somewhere. You can just use it. That's really cool. I've never thought about that before. That's a really cool way of having errors. So the error is like a tag, and you can't use X normally until you catch it. So it's interesting because you explicitly unwrap it, right? Yeah, that's really cool. I actually really like that. So let's test this out real quick. So let's say I had. Well, I mean, should I test it? Nah, I'll do it later. But yeah, that's really cool. I'm a huge fan of that. So I'm sorry. So I'm just thinking. are there ergonomics to like make this caching more simple? Right, like if I want to like in Rust, what like okay, so the way you do this in Rust, if I remember correctly, just bear in mind I'm not a Rust expert by any means, but whatever. So like in Rust, from my understanding, it would be like you know like let x equal, let's say like, okay, wrong one. Let's say like divide int ab like that, and like let's say divide int returned a option, right? An option int. What the hell? Okay, so then to catch the error, I would do, well, I could do like match x, right? And then like if it's sum x, then yeah, like print line had error. Well, okay, let's say it's result type, because that's what it really is here. So result int string, right? Also, where's the error coming from? Division by 0, but like, is this predefined, or like how are we getting that? I wonder. Okay, so let's say it's like an int string. Sorry, a U32, I guess would make more sense. Is that right? No, so it's like that, right? Oh, so it's not that though. How'd you do this? Is it result like this, or like this? Oh, whatever. Right. So anyway, so had error like that, right? X dot error, maybe, and then you do like error. Sorry, this is error. E has to be E as well. I mean, like you could shadow it, but sum x. But like, so like this is one way to do it, right? Like you have this. I guess you can also do the more like direct version is like if let error if let sorry error e equals divide int, or equals x rather, then print line has error e dot error. I don't know what the thing is, but whatever. Like this, right? So like this would be the Rust equivalent more or less. And then I guess like early return, right? If you're in a main function. So yeah, so like this is kind of just like an if let, but instead what's interesting here is catch has the role of unwrapping x. So here, if I've done this in Rust, what I then do is like I have to do like let x u32 or whatever equals x dot unwrap. Like I think I'd have to do this, right, to like shadow it. And like shadowing is like a good way to get around this, but ultimately I don't really like shadowing. There's probably another way to do this, to be fair, that I'm forgetting. But what's cool here is that in this language you don't have to do that. Instead, x just becomes a u32 automatically because we've caught the error. So we no longer care what the error is. We've freed x. And like what's interesting is I've been thinking before about like with like proofs, like having a language have like a way to prove that there's no longer an error. Like some way to check you know, for like program correctness, where the algorithm, the thing knows that you've checked the errors, and then like it looks ahead and whatever, and like therefore it like frees it, whatever. But in this case with C3, what it does is you are the one who says, yeah, I've caught x, so it's free now. Like you're declaring that you've caught it, which is what I assume this catch statement does, and that's really cool. So yeah, cool. I'm a big fan of that. That's crazy. That is indeed crazy. Let me put this in my Obsidian notes as well. Errors as wrappers. Rather, yeah. So inspired by C3. Yeah, so rather than having errors as types, we can have errors as wrappers over variables that are only removed once dealt with, right? And that's just so cool, honestly. Okay. I wonder if there's highlighting for this support. I mean, C3's been around for a while, so there really should be highlighting for this, but okay. I'll just do C++ for catch. Okay. So int x equals divide int. This would be an error running if b equals 0. What's b? Oh, right, for b, yeah. Does it say that? Yeah, b's there. Okay. It's quite important. Yeah, so x is a normal int now, so like this just works. That's so novel, but like also cool. Maybe I'm like overhyping it, and maybe I'm just also like fucking stupid, and this is actually a thing that you can do in Rust. But that's crazy. Is this a thing in other languages? Let me ask Claude about this. So I'm reading the C3 docs, and I've noticed that rather than using errors as types, it uses errors as wrappers over variables. So once you've checked for errors via catch, the variable actually becomes unwrapped. For example, an int boom automatically becomes a normal int once you've used catch on it. Is this a novel idea from C3, or is it used in other popular languages like Zig, Rust, etc.? Maybe I'm just blind. Flow sensitive typing or type narrowing. Yeah. Swift does it. Does it? Guard let x equals x. If let x now is a plain int in the success tope. TypeScript does it too. If x equals null, x is no longer t and null. Not just for errors though. Ooh, okay. So Rust doesn't do this. Rust uses if let okay val equals result for a new binding. And Zig also gives you a new one. In C3, the same variable narrowing in place, tied to an error fault. Interesting. Okay, cool. So this is also present in Swift. Stop! In Swift with its guard syntax, and TypeScript also has this for general types, for general either types. Yeah, like unions, right? Tagged unions. Honestly, yeah, having this in general for just unions, like, it's just really useful, right? Because like you've confirmed which one it is. Although really it's more for errors, right? I think. Okay, so how would you handle errors Okay, so how would this be handled in Rust? I do want to see a direct comparison here. So what's the official name? Type narrowing. The official name is type narrowing. Right, so in Rust it would be this, result like this, let x equals match, error, okay, val, let y equals x times 2. Yeah, so like you shadow like this, right? But the difference is that this is redundant. And then like you have to use a match statement, right? Or more idiomatically. I mean, yeah, but like if you want to handle it, obviously, right? Yeah. So like this is better. This is better. Because you just catch it. And like I like this pattern of like we have our code here, right? We handle errors and early return here and then continue. Like it's a really good pattern where you catch errors first and then write code normally afterwards. And you see this in like for functions, right? If you're writing a function, rather than having like an if this else this for handling errors, you just put if error at the top, return, and then you can continue with your function in the first like scope, whatever, like the base scope. Whereas this is like a scope here. So like the other way of writing this to kind of show what I mean would be, instead of doing like if catch, like the other way of doing this would be okay, yeah, so I don't have indentation. I should probably install that at some point. Like whatever, right? Like let's say I have this and I do this, right? Some may be tempted to do this. So if not catch error equals x and do this. Int y equals x times 2. Right? Yeah, something like this. Like this is what people like kind of like instinctively do, but it's a lot cleaner if you just invert it. So I can invert the condition here, and then just put that up, and then just remove this else, and then I just have this instead, right? Like that's a really clean pattern. This is not that. I mean, I guess it kind of is, right? But like it's just so much more more verbose. And Rust does have if let, but like that's for like usually you use if let on a successful value and not on a error value, so it's quite different. So yeah, like this is really like I will say this is very C-like, and I like it for that. Like it feels very very fitting. That's awesome, dude. That's just so cool. That's gonna be in my mind the whole day. One of my friends is a big Swift user, so I'm gonna ask him about that, because that's just so cool. It's getting smaller. Yeah, that's definitely smaller. So we got reflection with macros. Okay, print fields for each field type. Yeah, so I have mixed feelings on like how macros should be handled, but like $, I guess, field name, field offset, field size, type members. Okay. For each field in type members, printf function, and for each. I mean, it's something, right? Like it's still better than C's, obviously. Generics. Let's have a look. So struct stack type, size capacity, size, type elements. Okay, and that's it. So it just works. No template type name. I mean, like you don't need template type name anyway. Type name anyway. But okay, so but it uses like this syntax here with the angled braces. Void stack.push, stack this. Okay, so as this, that's interesting. Ooh, wait, stack.push. Okay, so it's explicitly defining it as part of it. Because like I know one thing that C programmers don't like about C++ is how you can have functions inside classes, but this is using dot syntax still. but like you are defining it explicitly as stack.push. That's really cool. I like this a lot. I do like this. In Rust, you do like impl, right? Impl for a stack that I have push inside. Or like for Zig, I think you can put push inside the struct, but then like you have to do the explicit this, right? But for this one, you just straight up define stack.push. So then if I use stack.push, that's like really intuitive, right? Because like I've defined stack.push, so intuitively if I do stack.push, it would just work. But then the issue here is that, like, let's say I use like stamp, which wasn't an existing struct. I'm guessing that wouldn't work, but it is interesting. This is quite cool. I do like I've mixed feelings on it, because like it is just like a namespace at the end of the day, and like it'd be cleaner if it was just inside the struct, or like defined externally. But it is cool. That being said, I guess it's not too different from C++, where like you can do you can do stack : push, and like that is valid C++, like a valid way to define a function. The thing is, you first have to declare it inside the struct, but like apart from that, it's actually this pretty much the same. But yeah, using dot is quite interesting, because it just matches the cool convention, which I find quite cool. So that's generics, pretty simple. Distinct types. So you have aliases, okay, and type defs. What's the difference? B equals Y. What's B? So B is an int, Y is a ID. Right, so an alias can be converted, a type def cannot. Okay, that's good to know. You can use explicit conversion though. That's cool. And we do have C-style casts, which I do like. People don't like them in C++ because they're unsafe, I guess. But I think, obviously syntactically they're just very convenient. More convenient than static cast, so it's cool to see that come back. YX SS? Wait, S for what? Signed integer, I guess. I was thinking string before. Okay. Cool, yeah. Makes sense. It makes sense, right? Like, this feels intuitive. Okay, so let's have a look at the docs now. I should go a bit deeper into this. Wait for my friends to fucking text me, because again we have an exam in like 2 hours. Java exam, by the way, which is why I'm doing this, because Java's not too difficult and the exam's also not too difficult. So introduction. Should I zoom in here? Optionals, so ergonomics and safety. Optionals to safely and quickly handle errors and null. Defer to clean up resources. Slices and for each for safe iteration. Context and comments add constraints to your code. Automatically free memory after use in @pool context. So there is defer. Slices are good. For each is also safe. Contracts and comments to add constraints to your code. Ooh, what? Contracts and comments. Okay, that sounds interesting. Performance by default. Great. Write simmed vectors to program the hardware directly. Access to different memory allocators. Yep, Zig has definitely popularized that. Zero overhead errors. So what's zero overhead? Just like okay, I guess like performance overhead. Fast compilation times, unlike Rust. LVM backend for industrial test optimizations, very good. And easy to use inline assembly. So yeah, this is great. I almost wonder, honestly, if this language releases, when is C3 planning version 1.0 release? What? April 2028. Okay, so it'd be a while. But honestly, I could see myself using this language. Like, even for someone like coming from C++, this is really attractive so far. More so than other languages I've seen. Because, like, it's just, the ergonomics are crazy right now. But anyway, maybe my opinion will change. Batches included, dynamic containers and strings. Yeah, unlike C, right? It doesn't have any of those. Cross-platform abstractions for ease of use. Cool. Access to the native platform when you need it. Nice. Full CPI ABI compatibility. Very important. Also very easy, because C's very simple. C++ though, that's the big one. It says C++ here, but it doesn't mention it here. C3 can link C code, C can link C3 code. Also awesome. So I can write like parts of my code in C3, and I assume it will compile statically, which is great. Modules and namespace code. Modules make, yeah. So for modules and namespaces, um, yeah, it's a mixed bag. I guess you well, no, because you can define the module explicitly, right? Like this, and it's file wide, which I think is good. Because usually when I use namespaces in C++, I almost never use multiple namespaces in one file. In fact, I never do, full stop. And when I do use a namespace, it's over the entire file. So like just having that is just so much more convenient. Rust does it by file name, I think, which can be problematic if I want to like split stuff into different files, but I don't know. I haven't used enough Rust to really see the full extent of that yet. Modules making calculations simple with explicit control. Interfaces define shared behavior to write robust libraries. Interfaces, okay, that's interesting. Ooh, that's actually quite that. Okay, I definitely need to see this. I'm not super happy with how Rust does modules, by the way. I find that it's quite it's still not powerful enough because I need to be able to okay. So to kind of explain this, I have a project. I have a project where for again this xfbin library where I want to be able to have modular ways. Okay, so to kind of give you an idea here, the xfbin format is a container format for a video game, and within that it has different like file formats. So like nucc image, nucc audio, and and like modules, data, like stuff like that. And then like within those as well, there are formats, right? Like for images, you could have like PNG, you could have NUT3. NUT is like a Namco thing, like Bandai Namco. You have for like within like the data formats, you have different ones like player color param, main mode param, message info param. Like you have all these different file types, and I want them when I'm creating this library, right? To have like, well, I say library. It's a library collection, a library tool chain, whatever, where you have modular imports. So like, let's say I want to use for my project, let's say I'm creating a tool that works with only xfbin audio files, right? So I only want the audio stuff. So you would import my main xfbin library, which would like just handle the xfbin like file structure, and then you'd import a module, a separate library that hooks into my xfbin library to have the audio functionality to just parse that, and then that would seamlessly integrate, and that'd be great. So then I can have modular components without creating this big monolithic library, and it also means that other people can then contribute their own code, and then you can like choose your different things that you want, right? Because I don't like I really don't like monolithic libraries. It's not really great, and same goes for like things in general, like monolithic compilers and whatnot. Like I like modularity. I think it's very useful, very powerful. But in Rust, it's hard to do this because, I mean, I can't remember the exact the exact technical details, but something to do with having implementations for classes? No, structs, right? Structs and implements, yeah. So you can't define implementations for a struct outside of its module. Like I can't include a module, import a module, and then define the implementation for a struct it gives me. And that's really limiting. I need to be able to do that so that I can have my xfbin library, like the master one, and then have those modular components, import the xfbin library, and then define an implementation to hook into it. That's what I need, and I can't seem to do that in right now. I'm still figuring it out, so I might figure out something that works. I mean, because right now I switched to writing the same library in C++ first, because that's what the demand is right now. Although even in C++, I had huge issues with like one thing includes another thing, so then you have like this what do you call it? Mutual inclusion, which doesn't work because they can't include, like two files cannot include each other because it becomes like infinite. So it's I haven't had it work in C++ yet. I haven't found a way for it to work in Rust. In fact, for C++, I'm only creating the xfbin structure library. I'm not creating all like the components, like the module stuff, because it's not gonna work right now. So I'm only doing like the basic thing with C++. For Rust, I want to see if I can figure something out, but right now it's not looking good. But so yeah, and so I really want to find a language where it just works, and if C3 can do that, then I might have to just jump on C3, honestly. Because I've talked before in a previous video. I don't really care that much about the C borrow checker. Obviously, like, it's very nice for writing like clean and safe code, but like it's kind of like, I see it as like a garbage collector kind of thing, right? Where it's useful if you don't want to worry about like cleaning up your own memory, right? For like garbage collection, or like if you're like NASA writing, critical software, then like you want to avoid memory leaks and all that, right? But if you're just a programmer just writing your projects, and like it's not like necessarily like huge collaborative whatever, like what you're doing, then you don't need the borrow checker. So like, although that's a cool feature in Rust, if another language is more powerful than Rust in other ways, and doesn't have a borrow checker, then I'm happy to jump on that language, because I don't care about the borrow checker. If anything, it's kind of annoying sometimes. To think about it, like I'd rather just manually handle my memory and be fine with it, and then I get more features. Because Rust is a great language, but I've said before, because Rust is the first of its like kind of like to really like kick off, I think other languages are going to leverage what Rust has come up with and then do better. And that's why we already see it with Zig, right? Like Zig has looked at Rust and said, I like it, but let's do better. In fact, I actually, to be fair, Zig has existed before Rust, but like it's definitely borrowed some ideas from Rust, right? And like functional programming. So I don't think Rust is going to take over as much as people are saying. I think other languages like Odin and, well, we'll see about C3, but like Zig, that are like also upcoming and whatnot in development, I think they will provide good competition. So for me, when choosing a language, I'm very curious, because I know the perfect language. People say the perfect language doesn't exist, but we can get closer. So anyway, interfaces. I'm very, very curious about that, because I don't think Rust has interfaces like this. So, and then generic modules make extended code easier than C, and simple struct composition and reuse with strict subtyping. Actually, I wonder if my friend Capillarni, I wonder if he knows about C3. I mean, he does, obviously, but like I wonder if he has used it or like looks into it much, because he is the kind of C++ programmer who only uses C++ because C is just so unergonomic that like if you want generics and like namespaces, then using C++ is just the way to go. So that's why he uses C++. But I'm sure that he'd prefer a different language that's more like C. So actually, he is quite interested in Zig. He cares less about Rust and more about Zig, because he's like that kind of guy. So I wonder if you'd like something like C3. Macros without a PhD. Yeah, cool. They're still evolving, so things can get outdated. That's fine. So, hello world. We've seen that, so imports it. We don't actually need to define the module, apparently. So if I remove this, standard, nope, just IO, print n, whoops, that works, yeah, okay. So just looking here, semicolons, yeah. So this isn't perfect, but like again, like I'm used to C++, so like it's fine for me. But for me, the ideal language would just be like this, honestly. Maybe like this. Actually, just like this. This would be ideal for me, because then I have, yeah, like it's just simpler. I do actually like significant white space, by the way. But it's C inspired, so obviously it's going to be C syntax, and that's fine. I just wish that other languages would be a bit more ambitious, like Rust. The function name main is a bit special. Also proc instead of function, actually, like PC or something for procedure, or procedure process. I guess both fine. Function scope imports can use the shorthand. They can, so these are both fine. Oh, cool. Git diff. Oh yeah. I luckily forgot about that. Does that work here? I wonder if Discord supports it, actually. Hello. minus hell. What's the code to get that to work? Like the language code. Whoops. Code line number 21 GD GI. Is it? GD for get diff, right? G oh. What's huh? What's the markdown code for get diff? Diff. Oh yeah, cool. Yeah, that's cool. Oh man, that's awesome. I forgot that existed. Anyway, compiling, run it. If you're Windows, you have help.exe. Yeah. Nice. Putting Linux first. How to compile. Install LVM. Right, let's compile it. People binaries. Right, set up roadmap. Let's have a look. So 07 series can be run in production. There aren't 0 bugs, but fair enough. System library is less mature. Of course, design goals. Procedural language with a pragmatic ethos to get work done. Minimalistic, nothing unnecessary or redundant. Now this is hard. The redundant part is hard. C++ has many ways to do the same thing, so I do wonder how that is achieved in C3. C equals to C. Learning C3 should be easy for a C programmer. So far it's been great. Like, things are really intuitive for me. Seamless C integration, economic common patterns, data is inert. Like it doesn't react? Yeah. Like, what does that mean? By the way, I told Google that I want search results in both Japanese and English, so that when I search in Japanese, it would give me like Japanese search results. Instead, what it does is like I just type something, and sometimes it just gives me Google Translate into Japanese, even though like I didn't ask it to. Like, is Google actually brain dead? Yeah. Anyway. Right, so data's inert. I wonder what that means. 0 is initialization. What does that mean? Avoid big ideas. It's an idiom where types and codes are written so that 0 value is a meaningful initializate. I don't know what that means. So like if I say this equals 0, it just works? Or like if I construct a 0? I don't know. Avoid big ideas. Like what? So full C API compatibility, module system. Yeah, so we're gonna look into those. Right, so we've got examples. Okay, so if statements. Yeah. Same old. For loop. Also same old. Also have this for a while loop. For each loop, it's called for each, right? Actually, in C, how do you use for loops on? Are there for each loops in C? Because in C++, it's just called for, right? No, it's a macro. Okay, cool. So this calls a for each, which I think is fine. Reference. Ooh, is this? Oh, okay. So there's no auto. It's just there. That's cool. Again, same as C. Yep. Pointers, by the way, enum and switch. Okay, so enums have this. Fairly simple enums. Demo enum, height, switch H, case, whatever. I guess, okay, to be fair, if I'm going to switch to a language that isn't Rust, I kind of need... I don't need, but I definitely want enums. Like their tag unions. specifically for error handling, it's just so much more convenient. And also then like pattern matching as well to come with that, right? Low, medium, high, so for switch statement. Break is implicit. If you want to break through, next case, good. Explicit break required, they can't be empty. Yeah, fine. Next case, next case. Okay, enums are always namespaced. Good, thank fuck. Enums support various flexible. Like, dude, not being able to namespace enums in C is like such a thing. I mean, it's why they're capitals, right? They're capitalized, because otherwise, like, they just put the namespace. But this is just so much better to the point where you don't even really need to have them in uppercase anymore, do you? State. Oh, they're also reflectable. Yeah, cool. So they have reflection properties. Values, len, names. Cool. Oh, cool. Like that gives you strings. Oh, that's so useful, dude. You can't do that in C++ right now, and it's actually drives me insane. Duff's device. I don't know what Duff's device is, but okay. To, from, count. Looks legit. Defer. Defer will be invoked on scope exit. So defer IO print and defer IO print A. It will just print at the end. Yeah, so it's kind of like inverse programming, you know, which is interesting. So if I were to use this, like, yeah, so I guess an example is like hello world, right? So if I compile this normally, or whatever, like compile it full stop, hello world, but if I defer both of these, then I should get the opposite order. Yeah, world hello. Okay. Yeah, so it's kind of just like defer is a cool idea. It is a cool idea. I do have mixed feelings in it, but I haven't used it myself like much, so I can't really comment on whether I like it or not. It just seems like kind of annoying to like have to like defer a constructor, a destructor, when for like structs and stuff. But yeah, I get it. Because it is often relevant to run different defers when having an error return, there's also a way to create an error defer. Defer try, defer catch. By using the catch keyword directly after the defer, similarly using defer try can be used to only run if the scope exits in a regular way. Defer, catch, error. Okay. Interesting. Ah, okay, I see. So it's like catch anything kind of thing, right? It's like if anything goes wrong, just catch it and do this. And here you have this as well. So I'm guessing errors have to be strings then? No, this is an integer, isn't it? Okay, that's interesting. I wonder how that works in terms of like how because like in Rust you can you can specify the error, and then you can like encode like strings and stuff and like other data into the errors, which is really useful for library design. But for this, I wonder how flexible that is. But yeah, this is cool, defer catching and all that. Return not found with thingy. Okay, prints built-in not found BA. Because it's prints, right? Returns are not found. Note that we need to use void to explicitly discard the optional result. Oh. So there's no unwrap, you just cast it to void. Interesting. Struct types, alias callback equals function. Oh, what the hell? You can use aliases for functions? Oh, right. Well, it's a type, isn't it? Okay, that's cool. Ooh. Does that work? C++? No, that's quite different. Okay, this is interesting. So how do I use this then? Like, do I just do callback? Wow. So I can define a function in a struct. Weird. Very weird. Extremely weird. I guess it would work in C++ actually. But like this encodes, well no, because there's no name, is there? Yeah, that's funky. Status int, okay. Struct other, so you have substructs. Anonymous ones too. X dot value. Oh, okay. So why would you use this? I guess just to like kind of group data visually. Otherwise, it's kind of useless. But hey, it's a thing. And it also means that these can't interact with things outside of their scope, which is also fine. This is not a name clash, but this is a name clash. So again, like, yeah, the use for anonymous substructs is kind of limited, but it's cool. Union can be anonymous too. That's probably the most useful thing actually. Being anonymous, and you can have named ones too. Function pointers. Right. So this is a function pointer then, right? Callback CB at my callback. Yeah. So this is a pointer. Okay. And then but then you just call it as if it were a normal function. That's really cool. That's quite powerful. Error handling, right? So division by 0, we saw this example already, right? You use the tilde. Returning an optional result uses the exclamation mark suffix. Oh, okay. So rather than using question mark to pass it on, we do an exclamation mark, which says, yeah, just propagate it. But this is void. This is double. Divide, foo bar, ratio, catch equals error, then it's unwraps, right? Okay, but where's test may fail? That's not being called. Yeah, so if this is void, how's that work then? You just catch it. That makes sense. So because it's right, so because it's not like a type, the error's not a type. It's just like kind of like tagged to it. You can move the tag to other types, and it would be the same. That makes sense. That's powerful. That's actually quite powerful. Like just in terms of like how simple it is. That system. That's crazy. This is lovely. Because the errors are just wrappers over a type rather than their own type, they can also be the same errors can simply be transferred to other types, like an int being returned to a void or something like that. Yeah, that's cool. Function main double ratio equals divide print file string file. Okay, so this is like a proper example. Whoop, load temp file name, casting it to a string. Why are we casting it to a string? I guess I'm not familiar with what load temp does. The following function is not called an error, so we must explicitly discard it with a void cast. Called on error. Loaded and got. Okay, this is really messing with my mind right now. What is going on here? I get this, right? We're catching the error. It is a an enum. No, it's not an enum. It's an error type or something. Okay, file name. Oh yeah, because you have the context there. Fair enough. Using the switch statement instead of a match, which is fine. Uh, I don't get this. Why we need to cast a void? Discard what? Like if this errors, this doesn't happen. Yeah, that one I don't get. The above is only saying how optional is by skip call identification. Oh, sorry, I'm dumb because file is an error type here, right? Not called on error. So if this is an error and we try using it here, then this doesn't get called at all. I thought like it does get called, but it just like propagates the error. Because like that transfers to this. But then if we discard it with a void cast, can't this crash the program? I don't know. Okay, so but this is more idiomatic. Makes sense. Yeah, I mean this is what I would do. This is ignoring this, right? Yeah. So like again, like this is what I'm saying about like not putting like some people want code that's like just like this, but it's better to just like handle the errors first and then do the stuff, because then it's just so much cleaner. We can early return here, and then do that. Yeah. So I mean, you know, every single clean code video will tell you this, but like just leveraging early returns is one of the best things you can do. Contracts, right? So these are comments, are they? Because that's huge. Param foo, the number of foos, require foo, so we've got like Java docs. Foo more than 0 for less than 100. Okay, that's cool. So we're requiring it. That would be... Okay, yeah, so this is... So for requires, right, there's the difference between compile time catching and runtime catching. And how do you handle runtime stuff? Like, do you just throw an error and crash the program? Or do you handle it as if it were an optional, right? Like that's really interesting. Return number of foos, unsure return. Again, but again, like how are you ensuring that? There's another page here. Okay, I'll come back to that later. Contracts. Okay. Struct methods. So did I miss something here? No. But it helps us optimize the code. So like, are they strict? I wonder. I know contracts are coming to C++ as well, or maybe they're already here. I can't remember, but that'd be interesting to see as well. It's possible to namespace functions with a union structure enum to enable dot syntax, right? So foo.next, just call that, right? Oh, that's right. Sorry. So it's actually type.next, and then you have here the name.next. Yeah, because I was thinking before, like how it's cool, like this is equivalent to this, but obviously it's not because this is a name, this is a type, but still, yeah, it's just cool. Macros may be immediately evaluated. I mean, but like, just in general, I honestly don't like dot syntax that much. Like, I've grown to dislike it. I'd much rather just have a language where you either put it inside or use piping. I think that's much better. And have piping as like a global thing, right? So like you could, if you wanted to, you could pipe like 5 into add 3. And that's that. I mean, that's idiomatic, isn't it? Or like pipe a format string into like the format specifiers. Yeah, I don't know. It'd be cool. Macro arguments may be immediately evaluated. Macro foo AB, which are in A, B. What? Okay. Like square 2 returns square 2. Oh, okay, it's a function. Sure. Return foo square plus b. Error function should be followed by ... or prefixed by ampersand. I assume this gets the address, right? I wonder why. I mean, it's a pointer, and then this, yeah, like course attacks. I mean, I guess it's consistent with how C does it, I think. Macro arguments, we have deferred evaluation, which is basically duplication of the expression using var syntax. Macro add foo. Oh, is it cool like add foo? That's cool, I guess. I mean, I don't know why you would use at, but okay. Improve macro errors with preconditions. Yeah, now this is good use of macros, like to make them type safe. Yeah, can almost by hello. Cool. This is very good. Compatible reflection, coming to C++, but with, you know, less syntax, because C++ has so much technical debt and syntactical debt, whatever. This prints on x64. Okay. Compile time execution. So for compile time execution, do you have to put it in a macro? Maybe. Const long fib19 equals fib19. And this is done at compile time. Fair enough. I wonder if you can use memorization compile time. C3 macros are designed to provide a replacement for C preprocessor macros. They extend much such macros by providing compile time compilation using constant folding. IDE friendly. However, if you're doing more complex compile time code generation, you should use exec and related techniques to generate code in external scripts. Okay, yeah, I was going to say, but interesting. Struct vec2 for operator overloading. Yes! So for operator overloading, vec add, vec sub, and then at operator plus. Okay. So I'm wondering, does a name matter? Or do you just do whatever and then say, by the way, an alias for this is this? Because that's cool. I do like operator overloading. I know people generally don't like it, but I think the way Rust does it is the best. Where you have a struct. Sorry, now you have an implementation for something, and then if you overload, if you implement like the plus operator for that struct, then you can use it. Through traits, that's the word I'm looking for, traits. I think traits is a really good way to do that. Like implement the addable trait, right? The add trait for vec2, right? Now, mind you, I can't remember if that's how Rust actually does it. The thing is, Rust just like, for Rust you implement like add, the function called add, as opposed to the plus operator. That's what I don't like. I would much prefer if it actually was like called plus, with like the symbol plus, but whatever. Yeah, cool. I think C with overloading is just cool. I like it, but like having a good way to do it in C++, it's not as clean. Generics stack. We've seen this example a bit, right? Looks very simple. Just do that. What I wonder though is, how does it deduce which ones are allowed, right? I mean, I guess for a stack, anything's allowed. But like, what if I want generics where I only want to allow numbers, right? How would I enforce that? Would I use the contracts to say like the type must be a number or something? Maybe. But then at that point, it gets really messy because it's like, I feel like that's more messy than just having like traits or something. But you know, this language doesn't necessarily want to do that. But I feel like it's quite important. Macros, dynamic calls, an interface, right? So an interface is very interesting. So an interface is a list of functions then, right? So is that like traits then? It's dynamic dispatch, struct Bob, okay, my name. Okay, so it implements my name, cool. Or it's derives from my name, whatever. And then we have implementation here. So string my name, Bob, Oh, you do add dynamic. Why? Why is that necessary? And why do you need to pass in Bob like that? Ad hoc implementation. So this works for anything? Surely not. It does work? Huh? What? So I can implement my name, even though. Wow. Okay, so I can implement dot functions for something that doesn't exist yet, as long as I declare dynamic. So then my wondering is this linked to this, or is it separate from the my name interface? Because this is what I was talking about. Where like Rust doesn't allow you to just implement stuff for classes from other libraries. But if I can do this, then that's really really important. So I do wonder what the extent of this is, the limitations and all that. Who are you? Okay, so there's an any type, which is very interesting. My name equals B. Sorry, my name A. I'm casting A because it's any. Okay, explicit cast, good. If not at what? If not b dot my name by reference. That's weird. I've never seen that syntax in my life. B dot my name is a function. I see. So basically, if this is a null pointer, which means my name doesn't exist. Oh, cool. Okay, and then this works. Okay, I need to look into this because this is really good. This looks a lot like Rust traits, but a bit more flexible, and that could be more powerful. So that's really important to look at. Here, two class examples: simple text-based games showcasing C. Sorry, who is developing C3? Real quick, and like I know it isn't that popular either, C3. But like people, oh, it started in 2019, so it's actually quite recent, and like it's already on like 0.8. With 1.0 on the horizon. Obviously, like again, like it's less ambitious than Zig, so it can come faster. But yeah, I'm really rooting for this project because it has some really good features so far. So like I really wanted to get more popular because I think these should make their way into other languages. These features. Imports. Okay. We have random. Oh my god. Generating random numbers is not difficult. Although, why is it rand and not like random? I didn't have to prefix it. That's weird. Secret this tries while outer true. What the fuck? While outer. What the hell? Oh, it's a tag so that you can break to outer. Oh, that's cool. Yeah, no. This is good. This is a feature I've seen before, but I haven't really like clocked properly. Tagged loops. Again, inspired by C3. WLang. Breaking. Yeah, breaking or breaking. Breaking out of nested loops can be cumbersome, or like nested loops / switches can be cumbersome in C-like languages. And so being able to tag a scope so that you can break tag is really useful. Yeah, and the example given is like for Obsidian. While outer. Man, give me my Neovim combines. Yeah, like switch. Wait, what? A switch without an input. Okay, fair enough. Case foo, break outer. Breaks out of while loop. Yeah, that's really cool. Rock, paper, scissors. Sorry, let me read the rest of this. So you got a switch statement with no condition. That's cool. Quite useful, actually. Yeah. If tries equals 0. Can you switch on strings, actually? That's a pretty big thing. In fact, I mean, I know switch. I mean, well, I don't really know. I don't really know how switch is implemented in general, but I know it's faster than using strings. Maybe I know you can switch on string hashes. So it'd be cool if you implement a hash function for a class or a struct, like the string struct, for instance, then you can switch on it. I think that'd be really cool. Just like make switching more powerful. This uses if catch, nice. So you can do whatever you want to that. IO print n, thanks for playing. If minus tries equals 0. Goddamn. IO print fn, game over. Yeah, so like code. I mean, it's not like obfuscated, but it's not easy to read, which is my issue with C. But hey, it works. Rock, paper, scissors. Enum. What? Wait. What? So an enum can have tags. So it is a tagged unions. Hold on. That's okay. Good. Yes, please, bro. While true. Okay, so like this is a loop thing. But I mean, yeah, like why bother having a loop? Oh, sick. Okay, that's really good news, because otherwise, like, it's just really annoying to use the language. From original. So what's action here? It's an enum. Where's from original coming from? Like it takes an original number and then it puts it here. But random 3, is that like a max of 3? So like 0, 1, 2? Must be, because I assume it's 0 indexed. Yo, this is so powerful, man. I feel the power. So I just realized these are booleans, aren't they? Holy moly. So the switch statements also allow booleans, which means you don't even necessarily need to hash like a string. Like you could just use string equals this, string equals that, string equals this, right? That's awesome. Man, this language looks so hot. Honestly. What would it? It's also interesting how like a C C3 language, which is based on C, by the way, like it's meant to like be an improvement to C, is also a very attractive alternative to C++. Like what would C3++ look like is what I wonder. Because like you don't really need the object oriented stuff if you have like traits. My friends have woken up finally, 1 hour before the exam. My table's dusty. What the hell? Yeah, this is awesome though. I love this. I love this so much. This is low key so far the best language I've laid my eyes upon, which is crazy to say, but this is just so good. And like maybe like I'm blinded by like the cool feature. Wow, but like genuinely this looks really good. Cause like it's just C, but just more ergonomic, you know, and like it feels natural. Like the old stuff still mostly works, you know, like plus plus, minus minus, you know, for loops and all that, switch statements, like normalist ones, like they still work, but they've just been expanded, you know. It's like this is the true C++, you know. I guess that's why it's called C3. Like C2 was like C++ and C3 is the next one, or maybe there's a language called C2. I don't know. There probably is, to be fair. As usual, types are divided into basic types and user-defined types. So enum, union, struct, typedef, bitstruct. Okay. All types are defined on a global level. A global level. What's that mean? What? Yeah. What does that mean? So like you can't namespace them. So enum, union, struct, basic types. I guess are like ints and stuff. Oh yeah, I've seen this. So. The basic types, I'm not happy with how their naming convention is. But to be honest, I mean, it's not terrible. But like, yeah, I mean, like also like if you're used to C, you probably don't care. But I do think U32 and etc. is the way to go. All user-defined types. Plus, you can make aliases, but it's annoying for like library design. And like the thing is, they can't support both because then code just becomes messy. So it's yeah, I don't know. All user-defined types in C3 start with uppercase. So so that's by convention. That's fine. Yeah, you know, I definitely support that. So okay, so good. So then, if you're creating a user-defined type, it will not mirror the standard library types. My struct will be fine. My struct T or my struct not. Yeah. This naming requirement ensures that the language is easy to parse for tools. Ah, okay. It's possible to use attributes to change the external name of a type. External, like imported. So like if I were to call it from C, it would be like this. I mean, it like obviously it's a good way to do it. You could also just like type def, right? Or like alias it. I don't know why you can't do that, but like I know this is gonna annoy people who want their things to be lowercase, but for me who prefers using what do you call it, Pascal case for this anyway. Great. This affects C headers, but it's last. Okay, yeah. So it affects C headers. Yeah, that's fine. Differences from C. Unlike C, C3 does not use type qualifiers. Oh. Like what? Like const? Ah, what the hell? That's really huge. Const exists, but is a storage class modifier. Storage class modifier. I forgot what that means. Not a type qualifier. What do you mean? What do you mean? What do you mean? Define the scope, lifetime of visibility, and linkage of variables and functions. Scope, lifetime versus type modifier. How long lives in memory? This changes the representation of the data itself. Its size, position, or whether we hold negative numbers. Oh. What? Is that not how it's meant to be? I mean, cost just means you can't change it, right? Maybe I'm missing something. That sounds normal to me. Why would const change anything else? Instead of volatile loads and stores are implemented using volatile load and volatile store. Fair enough. Restrictions on a function parameter. Oh, it uses at as well, which is interesting. I wonder what at is reserved for, because I know it is for. It's reserved for Zig, or not reserved, but like it's used in Zig for like stuff. Restrictions on function parameter usage are implemented through parameter preconditions. Okay, that's in language common contracts. I will look into that. C3's equivalent of C's type def has a slightly different syntax in C3 and is renamed alias. In contrast, in C3, a distinct type is created when using C3's type def keyword. I do like how they, rather than add the alias keyword, they changed type def's functionality and replaced it with alias. I think that's better, because like they could have said, oh, people are used to type def, so like we'll just keep type def the same and like change alias, but no. Having like the more suitable name for the more suitable task, and then changing type def to a different task, that's good. I like that. As such, take care to not confuse C3's alias and type def keywords relative to C. Yeah, good. You know, don't confuse them, but recognize that this one makes more sense, so we've changed it. I think that's fair. C3 also requires all function pointers to be used with an alias. For example, yeah, cool. Function things. Null. Oh, it says null. Is it null pointer, or is null just the uniform null pointer as well? Get callback. Oh, you can define. No, that's different. Never mind. That's function callback. Yeah, it makes sense. Function void. The fuck. Function void a equals null, bro. Yeah. So you have to use callback for function pointers. It's a bit goofy, I guess, but I mean, like it's a bit like, why are we imposing this? But it's like a thing you just get used to. What? Sorry. What is that? not like distract myself here, but I've got like a bit of like a like a spot, but otherwise, yeah. Anyway, comparison properties. But by the way, I love that like I'm not like doing this every 2 seconds. Comparison properties. Also, it just feels nice to compile type properties. Types of built-in type properties available through property syntax. The following properties are common to all C3 runtime types. Runtime types. Are there non-runtime types? Alignment. Ooh, okay. So you can change this. Now this is huge. These are comparative properties. Fair enough. Alignment. The standard alignment of the type in bytes. Int alignment will typically be before. Right, so how do I change this? What does it say? Maybe. Like, are these just properties, or can I like... Can I change them? I guess I can't change them. It'd be cool if I could, though. But so this is really good for like reflection. But like reflection without having to like actually do any like crazy syntax, I just call it like a property. So good. This is so good. It just stores metadata inside the type. It treats built-in types as if they were like structs with like their struct fields. Perfect. Literally perfect. Down to the very minute detail. Like it's perfect. Oh, by the way, the boys season 5. The final episode has dropped already. I haven't watched it yet, so I'm avoiding spoilers. But alignments. Yep. Kind. So pointer struct. Okay. Nice. CName, which is a string with the extra name of the type, rarely used. Name, QName, full path. Why is it Q? Oh, qualified. Size versus alignment. Oh, alignment size. Okay. Type ID, which is type ID. Okay. Methods. Is that like an array? Get tag. Okay. Has tag. Has equals. Is ordered, is substruct. Ooh, okay, that's interesting. So for Rust, you would check if it has a trait, like has EQ or something. I mean, I don't think it has EQ specifically, but you check it like this. In this case, it treats equals ordered and ordered as built into the language, as opposed to being like a trait that is implemented externally. And I don't know, like I like Rust for how like it's like kind of like atomic, right? Like rather than implementing core features like optionals and stuff as like built-in language features, they're actually derived from other language features, and like they're built upon that, which is cool, and it makes it a lot easier to learn the language, and also makes the language a lot more flexible. But the downside is that it's less straightforward. Like you lose the ergonomics of having like these hard coded ways to do things that are convenient, and like Zig takes advantage of this with like how it does errors, right? Rather than returning a struct of like, or like an enum of option whatever, like you just do like an exclamation point, with like the types whatever. So that's quite different, but it's quite interesting. And I like both sides, so it's hard, but has equals and is ordered. I'll definitely see how this works. Also, I wonder how it implements equals. Like, do you just overload the operator, or what? Basic types are divided into floating point types and integer types. Okay, they're unsigned or unsigned. Yeah, I mean those are the only types, right? You got bool as well. I do wonder how it actually does bool. Oh, okay, it's there. But like bool would be true and false, right? So like in C++, booleans are built in, so you have like true or false. That's fine. In C, I believe they are actually, but they used to not be. And I only know this because the Z10 editor binary template format thing, it doesn't support booleans, which is really annoying. So, and that's only because C didn't at some point. I don't know if it does. I could look it up, but I'm lazy. So booleans use 1 byte, but they're stored as 1 bit, but they're stored as a byte. I wonder if that changes if you pack them into an array. The thing is, it's not good. You use a bit array, right? A bit array, yeah, a bit array, which is what C++ should have done instead of its horrible vector implementation. You have ichar and char. Char is unsigned by default, so same as C. Short and ushort, int uint, long ulong, int 128, 128, I pointer, u pointer, okay, and then size and usize. Oh, size is just 2 things. Why is it SZ? That's weird. I guess so. Like it is. Oh yeah, I know why. Because otherwise it would conflict with like names like size, and that's really annoying. Which is fair enough. That's very fair. Size T as well, verbose. Yeah. Now, my qualms with this, right, is that why are we still using char, short, int, long? Like, why could we just use U8, U16? And I get, like, it's because C programmers are used to this, used to that. But I feel like changing these, like, I feel like it's not that controversial to change these names. Like, int, long, short. Yeah, I don't know. Bool, integer type properties, integer types, except for bool, have the following type properties, max and min. Nice. So again, these are properties. So you just do colon, and you just get it. It's so nice. All signed integer arithmetic uses 2's complement. Okay, good. It's standardized. Integer constraints are constant. Sorry. What? What does that mean? What do you mean they're 12, whatever? I don't know what that means. Integers may be written in decimal, but also in binary with the prefix 0b, octal with 0o, thank God, those who know, and hexadecimal with the prefix 0x. Nice. They're written in decimal by default, right? Is it meant to say between? It can't be, because these numbers don't make sense. I don't know what that means. For the case of binary, octal, and hexadecimal, the type is assumed to be unsigned. Right, so to do signed, like by default, you mean? Oh, I see. Okay, so I don't know what the fuck this is, but my assumption is that integer constants are signed by default, and to get them unsigned, you don't, right? Am I tripping? What is this? Why does it say this? What does this mean? This must be like some kind of like parsing error, right? I don't know why it says that. Okay, if you know, let me know. In the case of binary, octal, hexadecimal, yep. Furthermore, underscore, nice. Integer is literal suffix. I mean, very minor thing, but ooh, mind you, it is quite useful for hexadecimal. More so than decimal. This is really useful. Integer literals follow C's rules. A decimal literal is by default int. If it does not fit an int, the type is long or int 128. Actually, let me just add that real quick while it's still in my head. Underscores to separate to underscores between digits. Inspired by I say C3, but I've seen other languages do it. The other one that stands out to me is Odin also does it, I think. Yeah, so just like, I mean, it's very straightforward, isn't it? 1, 2, 3 underscore. Actually, can I just use Odin? Odin. Yeah. 1, 2, 3 4 5 6 0 0 0 7 8 7 8 9 or 0x. Very cool. 7 E 4 4 or 3 3. Why not? I guess underscore 4 9 B 2. Huge. I love that. That's goofy. Okay. Integer literal. A decimal literal is by default int. If it does not fit an int, the type is long or int 128. Oh wait, yeah. So sorry, it supports int 128 out the box. I kind of glossed over that. That's useful for simd. I don't know how useful it is for general usage, but hey, cool. It should be standard at this point. If the literal is suffixed by u or u, it is instead assumed to be a uint. Okay, so you can do that. Why? What's capital? Like, is there a difference there, or just the same? I guess a C might support both, so it's just being kind, but it really shouldn't support both if they're the same. Binary, octal, and hexadecimal will be implicitly unsigned, so they're already. If an L or L suffix is given, the type will seem to be long. Yeah, so it's just the same thing. Double L is int 128. Yikes. A long. So a long is now actually a long. Huge. If the UL or UL is given, the type assumed to be ULong. If UL, UL. I mean, the thing is, right, like, these sizes aren't standard anyway. Like, long was never necessarily a U64, and int was never necessarily an I32, right? So, like, why are we using these names and giving them specific types? I think it, like, just change it to U32 and U whatever, you know? Because, like, this is also controversial, having these names. And, like, having U int 12H just there, when, like, you have long and stuff like that, that's just weird. Like, U int is, like, 32. That's a mistake. I don't know if they'll ever change it, like at this stage of the development, but I really hope they do. 2cc, 4cc, and 8cc literals. I don't know what 4cc is about. They're used to identify binary format type. C3 adds direct support for 4-character codes, but also 2 and 8 characters. C3 would convert to a U short or short. Test converts to U or int. Foobar 11, U long or long. Oh, so is it just like a character as an integer? For data formats. Oh, is that the official name? I didn't know that. I just called them file signatures, but I guess 4cc actually makes sense there. That's cool. That's cool. I like that being built in. So just in general, 2-character strings, which use single quotes. Oh, that's smart. That's smart. Okay, because by default you cannot use double. So you cannot put multiple things in a single character unless it's like Unicode. But this works. That's awesome. Dude, why does this language have so many good ideas I've never seen before? I mean, I've seen. Okay, I have seen them before, but like there's some stuff I've never seen before, which is so cool. 2cc etc. as literals. Again, inspired by C3. 2cc, 4cc, and 8cc. Is that how you spell it? Are just integers represented as character strings. Can use single quotes for these, right? For these, since you can't have multiple chars inside single quotes otherwise. Anyway, that's so cool. I'm in love, man. I am in love with this language. So like C3 would be a U16, or is it I16? Just U16 makes sense, right? Yeah, okay, it is uint, which makes sense. Like NUCC would be a U32, and like I don't know, foobar 11. Okay, I'll steal that example. U64. Oh, I love that so much. Dude, it's so cool. Why doesn't C have these features, man? Or C++? Like these are just no-brainers. Oh my god. I mean, like if you have thought about it, it's a no-brainer to include. Yes, endiness. Yes, okay. Dude, unironically, this is useful not just for like visually, right, but also just like fucking for endiness. For endiness, it's so important as well, because like to get endiness to work otherwise is so annoying. So this is huge. This is huge. Base 64 and hexadecimal literals work like UC4cc, 8cc. In that it's laid out in byte order in memory. Each is the format B64 thingy base 64. Okay. Oh, like a string. Oh, okay, cool. This is double quotes. That's single quotes. So I'm not sure how that's meant to work. Hex-encoded values work as base 64, but with the format X. Okay, so those work as well. Right. Why is it a char pointer? So why is the char pointer like this? Char array pointer? What is it? Is it a char array of char pointers? I don't understand the syntax yet. In our case, we would encode this as foobar 11. Okay, sure. I don't know why you'd use this instead of just using the literal. right? The literal, unless you want to like import it from another language, import it from like some other thing, like you're reading a string. But okay, sure. String literals are raw strings. I mean, yeah, I'm less hyped about that because I don't know when you'd use that. Although obviously having base 64 is quite important, I guess. Although again, like I don't know when you'd use that. Maybe if like you want to encode an image or something easily. Oh, actually, no, that's valid, right? Because then you can directly encode like data, like images, into your program without taking up like loads of space, like visual space. Although really you shouldn't be doing that anyway. The language should have other ways to import images statically. String literals and raw strings. Regular string literals is text enclosed in this, just like in C. C3, okay, so but like, are they called char? C3 also offers another type of literal, raw strings. They use, so yeah, so I've seen this in, I can't remember what language, maybe it's Odin as well, but they use backticks for raw strings, which is cool. No escapes, no escapes. Write a double character to span across lines. Cool. I don't think these are even used for anything else in C, right? Or C++. I don't think backticks have any use at all. But I might be wrong about that, which is really bizarre. Z string, I mean, it's not bizarre knowing that old keyboards might not have had them. In fact, maybe you can use backticks instead of quotes. Am I tripping? I might be wrong about that. Anyway, string baz equals assembly. Yo, can we not highlight stuff? That's an accident. Disable on the website. Hide until next visit. Yes. Can I do that? I don't know. Same as using these. Cool. Floating point types. B float 16, float 16. Alright, we kind of missed these. Yes, you got a brain float, double. Cool. Calling float 16 and not half float. A bit strange, like H float. But again, like at that point, why are we even calling them float and double, you know? Support is shortly complete, and not all systems have native support. Ooh boy. Max, min, infinity, and nan. Okay. Why is that a property? I wonder. Yeah, why is that a property? I guess it just returns it. Oh, that makes sense. No, that makes sense because like then you don't have to like encode it into the language itself as keywords. Fair enough. Floating point constants will use 64-bit precision, just like for integer constants. It is allowed to use underscore, but it may not occur before or after a dot immediately. Okay, and there's also e. Nice. By default, a floating point type is a type double, but the suffix f is used if it is instead of float type. Okay, so it's double by default. Sure. C compatibility. C interop. Nice. There's a whole core library for that, I guess. C char, C short int, unsigned short int, yeah. What are these though? What makes it a C int? Is it just like platform? Yeah, I guess it's platform specific, right? Floating double always matches C counterparts. Note that signed C char and unsigned char will correspond to I char and char. Okay, you got pointer types. So you got foo pointer. Okay, this is a property. So you have the inner property, which returns the type of the object pointed to as a type ID. Very good. So it sorts the type, but not the size. So no fat pointers. I mean, I know there are spans because I mentioned it, but an optional type is created by taking a type and appending tilde. Yeah, tilde. I like tilde for like maybe. You're like maybe tilde, but putting it at the end is weird. I don't understand why it's not at the start. Maybe it's like a parsing thing. An optional type behaves like a tagged union. Holy tagged union. So that's I assume they're gonna talk about tagged unions, right? Do they? I mean, obviously later in this, but in this overview, maybe not. Containing either the result or an empty, which also carries a fault type. Once extracted, a fault can be converted to another fault. Assign the excuse in I to B. Ooh, this is catch. But that's an at catch. It did say the documentation might be outdated, but I don't know. I don't think it's that outdated, is it? Fault def missing. So you define the result of a fault. I equals IO end of file. Assigning an optional result to I. Fault B equals missing. Whoa, what's fault? Is that a type? Assign a fault to B. B equals catch I. What the fuck? So the fault is the whole type, like this. Only variables, expressions, and function returns may be optionals. Function and macro parameters may not be optionals. Okay. Sure. An optional value can use a special if try and if catch to wrap its result or it's empty. It's also possible to implicitly return if it is empty using exclamation mark and panic with double exclamation mark. Nice. Turn by the optional type and error handling. Read the page. Okay, I'm going to read that later. The fault type. When optional does not contain a result, it is empty but contains a fault, which explains why there's no normal value. A fault can have a fault has the special property that together with the thing plus suffix it creates an empty value. Okay. Int x equals IO error. Optional empty. Fault y equals IO error. Here it's just a regular value since it isn't followed by tilde. Oh. Okay. However that works. Yeah, fault def defines new one. Okay. Like the type ID, a fault is pointer sized and each value defined by fault def is globally unique. This is true even when faults are separately compiled. Oh. How does that work? The underlying is it like a hashing thing? The underlying unique value may vary. The underlying unique value may vary each time program is run. Okay, I need to look into that. The fault type only has one field description, which returns the name of the fault. Namespaced, nice. Okay, so you can't namespace them. It keeps saying global scope. I don't really know what it means by that, because I like namespacing is really important, like for the module at least. Type ID holds the runtime representation of a type. Using type name type ID, a type may be converted to its unique runtime. Type ID A equals type okay. So that's a type. That's cool. The value stuff is pointer sized. Yeah, this is coming in C++ with reflection. There's like a special like type. My friend's getting a company laptop for his job, and he said that if he gets to keep it, he'll give it to me. Let's go. That'd be cool. Get fucking Nix OS on it. Nice. So it is strings. At runtime, only a few are available. Right. Okay. So it's different depending on runtime. I wonder how that's enforced. Kind, parent, inner names len. Okay. The any type. Variant type, which is variant struct containing type ID plus is it? A void pointer. Okay, that makes sense. Well, it's possible to cast any pointer to any pointer type. It is recommended to use any cast macro, or checking the type explicitly first. Any cast. What does that mean? With any cast macro, the return will be an optional, which is empty if there's a mismatch. Okay, so that's actually built in. Int x any y equals the pointer to x, so int pointer now. Change the pointer to an x. We have to cast it. Double pointer, double y. Ooh. I do like this. People don't like the idea of casting like this. I know it can be like really messy, but I actually like it. It's cool. I think being able to do it is cool. You know, don't be a I don't know where it is. Buzzkill? Yeah, buzzkill. You can use a switch to check any type as well. Yo! Dot type. Yeah, that's cool. This might actually be possible in C++. I'm lying, because switch isn't that flexible. But maybe with pattern matching? Dude, oh my god, I just love the switch statement. It's so... I love switch when it's expanded, and this is the final form of switch right here. What this language has is a final form of switch, and I love it. I love it. Know that in switches, if a subject is passed in, it will take priority. Cool. Yeah, obviously that makes sense. So you can match on structs as well. Very important. So like it doesn't even need match, because like the switch is so powerful. Just like less. I mean, I say less nice syntax, but like as soon as you get rid of break being a default in switch statements, Like, it just becomes so much less hassle to write. Like, I know like it's minor, but like it really just takes up so much space, having all those breaks. Any gets access to files, some any's a type and pointer. So so it is like a struct. I mean, it says like a struct, but I assume it's not that simple. Like, I assume like I assume it's not defined in the language. I assume it's defined, implementation defined. No, what's the word? Like, it's not like defined via the language's library. It's just in the library built in, in the language built in. Any cast returns a pointer to type pointer or type mismatch if types don't match. Any cast. Oh, I see. So cast it. Okay. Any make creates an any. Any with type 2 changes the type as inner. Retypes the type of any to the inner. Okay. Okay. Arrays. Yes, huge. So so arrays are indicated by size. Oh, I see. Okay, so you put the thing in and then you put the size inside. Like C. Yep. After the type. So that's different from C, and it's better. Slices use the type for. Slices use the type thing. What do you mean? For initialization, the wildcard. Oh, it's a wildcard. Okay, I thought it was a pointer. That is a bit confusing. I'm not gonna lie, having the wildcard be the same as pointer, but yeah, I get used to it. Okay, so vector types. Vectors use. Okay, so are vectors built in or? Vectors use size after the type. Is this optional or? I assume so. Float. Oh no, it actually uses. Oh shit! What? I mean, sure. I guess with restriction that vectors may only form out of integers, floats, and booleans. Whoa. So you can't use. Whoa! What? Why? Okay, there's gotta be more to that. Similar to arrays, wildcard can be used to infer the size of a vector. Yeah. You can only use integers, floats, and booleans. Okay, I need to look into that. Also, booleans? Would you not use like a bit vector? Array and vector types will support inner and len. Okay, that's funky. I need to look into that. User defined, like type def. Yeah, we already saw this. Alias, function prototype, same thing there. Nothing created there. Params of returns. Okay, so you got callback tests. Ooh, cool. So it does have name parameters. Thank you. Distinct type definitions. Again, Rust doesn't have named type parameters. There are so many things in Rust that it could have that it just doesn't, and they haven't added it yet, which makes me think that another language is gonna replace Rust. It has to, because language nerds they like these features, man. Constant init, sorry, equals int for type def. What's the difference between constant init and just? I don't understand that. My ID 1, my ID 2. This is 2. Error to my ID, use constant int to allow implicit conversion from literals. Use constant int to allow implicit conversion from literals. What? Oh, this doesn't work. But constant int does allow it to implicitly convert, but only for literals. Okay, sure. Inline in type def, use inline in the type def declaration. Sorry, which allows a newly created type def type to implicitly convert to its underlying type. God damn, this is quite complicated. So you can do I equals B, but not I equals A. Because B can be implicitly converted. But at this point, why not just use an alias? Am I missing something? I don't know. It's possible to use type def to create underlying types. An int will be 4 byte line. We can create a 2 byte line type using type def into line int, and then we can use the property. Okay, good, huge. Yeah, because I was wondering, can you change the properties? And you can. So that's like, it's just so powerful. Like you can't do this in C without like defining like a custom bit array or something. So like this is so important, especially for me as someone who wants to do like modding and like reverse engineering. Having that kind of control is really important, and I know it also matters a lot to like embedded system developers. I wonder what Zig does for this stuff. Because again, like Zig's very popular. You got sim types. Okay. I don't know much about simmed anyway, but cool. But he just adds simmed. Okay, for vectors, yeah. Type to type properties, any parent of, then generic types is the last one. No, not yet. Import generic list. Sync generic my list. Struct foo into x. It is for each type. Use the generic module. My list foo. Okay, so you pass it in like this, which is goofy, but and I mean compared to like C++, but this isn't C++. So this isn't meant to be C++. And that's an inline type definition. What the fuck? Prefer aliases. Oh, okay, so you can't do this, but you can use aliases, which is at least it's possible. And it also just makes like nesting templates not a thing, which I don't know. Okay. Contains the generic my list. Okay. Enum and constefs. These correspond to C's enums, C enums and constefs. Do they though? Because they look quite different. Struct types. See more about units and structs and bit structs. Okay. They do have associated values. Okay, so I'll look into that. Okay, so this has been great. This has been awesome. I did not expect it to be so good, to be so cool. Why is this not more popular? That's actually insane. God damn. Okay, so my exam starts in half an hour, so I gotta go soon. But that's so cool, man. I'm definitely gonna look into this later, just like more in depth, and also play more with the with actually making projects with it, and see what happens. But this language is beautiful, man. This language is actually beautiful. Oh, who made this? Who made this? It's on GitHub. Good. And there's also a Discord, which I will join. And there's a blog? Oh my god, bro, it just keeps getting better. Okay, let me not zoom in here. I'm kind of lagging right now. Don't know why. Compiler for the C3 language, actually because OBS. Sorry, let me fucking, yeah. So C3C, it has 5.5k stars, so like it's not unpopular, right? Yes, I'm gonna look more into this. I'm gonna look into the blog. Please, bro. Like, is it just for like things, or is it like more than that? Less kill off half the built-ins. Size of built-in. Okay, interesting. A 5-year mistake of unsigned sizes. Okay, interesting. The last v407 constef. Yo. This goes back far as well. A new error handling paradigm. Dude, I gotta look into this blog. Oh my god. This is a gold mine. Like, even if this like project doesn't become super popular. But honestly, I think it might. I think C3 could like come from behind, honestly. Man, this is so cool. This is so cool. This speaks to me on huge levels. Whoops. I just, yeah, open, accept. And this is Christopher L. Well, actually, what are the languages? I recognize him, which is weird. I don't know why. He's in Rust, he's in Zig, and he's in the Coding Den. Yeah, why do I look-y recognize this guy? Maybe it just looks similar. But, yeah, goat. Actual goated language he has created. And he engages with the memes. I hate this video. Wait, did this shit on C3? Okay, I'll look later. Anyway, yeah, I gotta go, but this is awesome. Oh my god, bro. C3 so cool. C3 so cool. Dude, just give me a language I love, man. Just give me a language I love. You know, like I've used Rust. I've seen Zig. I want to use Zig, but it doesn't look great. You like just like syntax wise, it turns me off. It puts me off. Odin looks good, But C3 so far looks the most promising. I do want to compare Odin to C3 because like even if you just look at the Hello World examples, they're quite similar, but Odin just has different syntax, like with proc for process or procedure whatever, and no semicolons, stuff like that, right? Like Odin has different syntax as well, which I do like. But even then, like C3 feels just familiar, and that just makes it easier to adopt, like soul wise. Like I feel it in my soul, you know. So like I do see why people would want a language like C3, which has the same syntax as C. I do see the appeal. But yeah, this is great, dude. We are in for the golden age, the golden era of programming, and the only thing that can ruin it is AI vibe coders, man. Fuck. So anyway, very exciting, very excited. I will look at this later for sure. Huge.